Welcome to this lesson. My name is Teacher Agnes, and today we are going to be discussing about how to find the GCD using the method of prime factorization. So in the previous lessons, we have learned about how to determine the prime factors of a given number. Now the same method can be used to determine the greatest common divisor. And if you remember, we said that the other name for greatest common divisor is highest common factor. So if you get the prime factors of any numbers, then you can get the highest common factor from the prime factors of a set of given numbers. So we're going to learn this using an example. So let us determine the GCD of the numbers 16, 40, and 60 using the method of prime factorization. So the first step is to factorize the numbers using the tree factor. So starting with 16, 16 is divisible by which prime number? 2. So 16 divided by 2 is 8. Again, we divide 8 by a prime number. So we divide it by 2, which is 4. Then we divide 4 by 2 to get 2. Then we proceed to 40. So 40 is divisible by 2. 40 divided by 2 is 20. 20 is also divisible by 2. So divide by 2, we get 10. 10 is divisible by 2. 10 divided by 2, we get 5. Now 5 is a prime factor itself, so we can't divide it any further. Then we get the prime factors of 60. 60 is divisible by which prime factor? 2. 60 divided by 2 is 30. 30 is also divisible by 2. 30 divided by 2 is 15. Now the next prime factor that can divide 15 is 3. So 15 divided by 3, we get 5. So 5 is a prime factor itself, therefore it cannot be divided further. Now, we will note down these prime factors using the power form. So remember the power form of writing the prime factors, the product of prime factors. So 16 will be equal to, how many 2's do we have? 1, 2, 3, 4. So 16 is equal to 2 power 4. What about 40? So 40 has how many 2's? 1, 2, 3. So 2 power 3 times 1, 5. 5 power 1. Then 60 is equal to, how many 2's do we have? 1, 2. So 2 power 2 multiplied by 3 power 1 multiplied by 5 power 1. So now we have expressed these numbers as a product of their prime factors. Now how do we identify the GCD from here? So the greatest common divisor or the highest common factor, common, okay? Focus on the word common. So we must check whether the prime factor 2 appears in all the 3 numbers. So we can confirm that yes, we have 2 here, we have 2 here, we have 2 here. Therefore, 2 is common, but 2 to the power of what? So here we have 2 power 4, here we have 2 power 3, and here we have 2 power 2. So which power is common? The power which is common is 2, because you notice that inside this 4 we have 2 power 2, inside here we have 2 power 2, and then here we have 2 power 2. Therefore, the power which is common is 2 power 2. We can't pick 2 power 3 because the 2 in 60 goes all the way to power 2, meaning that we only have 2 2's here. Yet here we have 3 of them, and here we have 4 of them. So the 2's which are common are only 2, because we have 2 here, 2 here, and then 2 here. So we choose 2 power 2. The next prime number that is here is 3. But you notice that in 16 there is no 3. In 40 there is no 3. In 60 there is 3. What does that mean? 3 is not common. It is not in 40, it is not in 16. It will therefore not appear in the value for the G.C.D. What about 5? In 16, there is no 5. In 40, there is 5. In 60, there is 5. Now, since 5 is missing in 16, then it is not common. Therefore, we cannot include it in the G.C.D. So, 2 power 2 is the G.C.D, which can also be written as, remember 2 power 2 means 2 times 2, which is equal to 4. And the G.C.D of the 3 numbers is 4. So we are going to do one more example so that you can understand this concept better. Now in this example, we are going to determine the G.C.D of 45, 90, and 120 using the method of prime factorization. So we begin by getting the factors of each of these numbers. So 45 is divisible by 3. So 45 divided by 3, we get 15, which is also divisible by 3. So 15 divided by 3, we get 5. That's the farthest we can go because 5 is a prime number and cannot be divided any further. Then we have 90. So 90 we divide by 2 to get 45. Then 45 by 3 we get 15. Then 15 divided by 3 we get 5. Next is 120. So 120 we divide by 2 we get 60. 60 divided by 2 we get 30. 30 divided by 2 we get 15. Then 15 divided by 3 we get 5. So now we can write down the numbers in their factor form. So 45 will be equal to 3 power 2 because there are 2 3's. So 3 power 2 times 5. Now the factors of 90 can be expressed as a product in the form we have 2, there's only 1 2, so it is 2 power 1 times 3. How many 3's do we have? 1, 2. So 3 power 2 times 5 power, there's only 1 5, so power 1. Then 120. 120 will be equal to, we have 2 power 1, 2, 3. So 2 power 3 times, we have 3, there's only 1 3, so we have 3 power 1 times 5, there's only 1 5, 5 power 1. Now we have 2 power 3 and then the number of 3's is just 1, so 3 power 1 times, how many 5's do we have? 1, so times 5 power 1. Now, how do we get the G.C.D from here? So to get the G.C.D, we identify the common factors, okay? We identify the common factors. So let's begin with 2. So do we have 2 in 45? No. Do we have 2 in 90? Yes, we have 2 power 1. And then for 120, we have 2 power 3. But since 2 is missing in 45, now to obtain the G.C.D, we check if we have any common factors. So we begin with 2. So 2 appears in 120, it appears in 90, but does not appear in 45. Therefore, 2 is not common. Then we check 3. So we have 3 power 2 in 45. We have 3 power 2 in 90. Then we have 3 power 1 in 120. So 3 is common, but 3 to the power of what? So since we have power 1 here, that is the least, then power 2, then power 2. That means we take the one with the least power, 3 power 1, because if you check even from the factor tree, we have 2 3's here, we have 2 3's here, and only 1 3 here. Therefore, the 1 3 is the one that is common. So 3 power 1 times 5. We have 5 power 1 here, 5 power 1 in 90, and 5 power 1 in 120. So the common factor there is 5 power 1. Now multiplying these two, we have 3 times 5, which is equal to 15. Therefore, now we can say that the GCD of 45, 90, and 120 is 15. Now for further practice, I'll give you a set of 3 numbers whose GCD you will determine using the method of prime factorization. So for your assignment, find the GCD of 8, 40, and 60. So make sure that you try this out using the method of prime factorization. So I hope you have learned something. Thank you and see you in the next lesson.